Today we're going to start section 4.1, polynomial functions. A polynomial is basically a mathematical sentence that has terms, coefficients, variables. In these examples, we have to decide if something is a polynomial or not. And honestly, it's easier to describe what a polynomial is by talking about what a polynomial isn't. So a polynomial has to be real number coefficients, so there can't be any i's, no imaginary numbers. The variables have to, or the exponents have to be positive integers. That means no decimal exponents and no negative exponents. Standard form means that you write the largest exponent term first, and then the rest of them in decreasing order. So if you've got an x to the fourth in there, you'd start with x to the fourth, then you'd write x to the third, then x squared, then x, and you'd end with the number that doesn't have an x. The leading coefficient is the number in front of the term that has the largest exponent, and the degree is the largest exponent. So in these examples, we need to determine if it's a polynomial function. We need to write it in standard form, so starting with the largest exponent term and then decreasing. State the degree, the type, and the leading coefficient. We'll talk about the type once we get there. So in this first one, first of all, is it a polynomial or not? I don't see negative exponents. I don't see any i's. I don't see decimal exponents. This looks good. So this one is a polynomial. I'm just going to write yes for polynomial. We need to write it in standard form. We would start with negative 2x to the third, then 5x, then 8. Whatever symbol is in front of the term, attach that symbol to the term that comes right after. Once it's written in standard form, we need to state the degree, the type, and the leading coefficient. Honestly, I care the most about the degree and the leading coefficient. This one has a degree of 3. We'll use LC for leading coefficient. The leading coefficient is negative 2. So the degree is the largest exponent. The leading coefficient is the number in front of the term that has the largest exponent. The type is really the same as the degree. So look at this chart here. A 0 degree is called a constant. A 4th degree is called a quartic. This one is a 3rd degree, so it's called a cubic. So this one would be a cubic function. Okay, example B. Is it a polynomial? Decimals in front of the x's are fine. Square roots in front of the x's are fine. The important thing is there's no i's, and the exponents are positive whole numbers. So this is fine. It is a polynomial. So take a moment, pause the video, and write this in standard form. See if you can figure out the degree, the leading coefficient, and the type. The degree is 4. The leading coefficient is the square root of 2. That's kind of a weird leading coefficient, but hey, it works. And it's quartic. Because the degree is 4, 4 means quartic. Number C, yep, I said it. Number C is not a polynomial. Why is it not a polynomial? Because there's a negative exponent. So you may want to point at the negative exponent and write something about that you can't have negative exponents. So negative exponents are not okay. In example D, it is not a polynomial because x is an exponent. X is a variable. We don't know what x is. So if we allow x as an exponent, x could be positive, it could be negative, it could be a decimal, it could be an imaginary number. We don't know, so it can't be a polynomial. So x can't be an exponent. Okay, take a look at E and F. Are E and F polynomials? They look fine to me, so pause the video and on your own rewrite E and F in standard form. State the degree, the type, and the leading coefficient. Did you pause the video? I don't believe you. I don't think you paused it yet. You should really pause it. Check over your answers for E and F. The one type that we did not see is quadratic. So just remember that a degree of 2 would make it a quadratic function. A degree of 1 would make it a linear function. A degree of 0 would be a polynomial that looks like this. It's just a number. There's no x's there at all. 0 means there are no x's. Okay, evaluate the polynomial functions for the given values of x. Parentheses are your friend. So I'm going to rewrite this 2 parentheses 3 to the 4th. So anywhere you see an x, we're going to put parentheses and then put 3 in its place. Minus 8 parentheses 3 squared plus 5 parentheses 3 minus 7. It doesn't seem to make a huge difference when you're plugging a positive number in, but when you're plugging a negative number in, it makes a massive difference. So plug this into your calculator. To do 2 times 3 to the 4th, to raise something to the 4th, in your calculator you would do 2 parentheses 3, close your parentheses, caret button 4. Then you would do minus 8, parentheses, 3, close your parentheses. For squared, you should have a square button, or you can do caret button 2, and so on. So if we plug this into our calculator correctly, let me type it in quick. Oops. Oh my gosh, I cannot type it in correctly right now. Minus 8 times 3... squared. You should get 98. In example B, this time we're plugging in x equals negative 4. So we are doing negative parentheses negative 4 to the 3rd plus 3 parentheses negative 4 squared plus 9. Pause the video, type this into your calculator. If you got 121, you did this correctly. If you did not use parentheses, you may have gotten 25 as your answer. Your calculator is doing right here, your calculator would be taking 4 squared and then sticking the negative on the front. And we don't want the calculator to do that. We want the calculator to take the number negative 4 and square it. So the parentheses are incredibly important to get the correct answer. Now, technically, I should tell you that for A, you should write your answer as f of 3 equals 98, but I'm not going to be that picky. And then B, g of negative 4 equals 121. Next, we're going to talk about end behavior of polynomial functions. End behavior basically is referring to what the ends of this graph are going to look like if we graphed the polynomial. So I'm going to make my own chart over to the side. First, we're talking about odd degree. So odd degree. Remember, degree is the largest exponent. So we're talking about things that have like x to the 5th as their largest term, or x to the 3rd, or just plain x, or x to the 7th. Any odd number as the largest exponent is going to be an odd degree polynomial. What I want you to notice is the two ends of the graph point in opposite directions. So I'm going to write down odd opposite. And I just remember odd opposite, my two ends are going to point in opposite directions. Even degrees are things like x to the 6th, x to the 4th, x squared. Your largest exponent needs to be an even number. And what I want you to notice is that the ends point in the same direction. So even degree, it's going to be in the same direction. The difference depends on the leading coefficient. The leading coefficient is always going to control the right side of the graph. So if the leading coefficient is positive, the right side of the graph is going to point up. So I'm going to do this in another color and say LC positive, the right side is going to point up. If your leading coefficient is negative, the right side is going to point down. Even degree, if the leading coefficient is positive, the right side is going to point up. If the leading coefficient is negative, the right side is going to point down. So the right side is always controlled by the leading coefficient. The other side is controlled by the degree. So odd degree, the other side needs to point the opposite direction. Opposite direction. Even degree, same direction, same direction. So these are the arrows that I want you to use. When it says sketch the shape of the graph, really we're just going to do the arrows. What's the left side doing? What's the right side doing? So in example 3A, this one, we first need to look at the degree. So the degree of this one is 4. 4 is an even degree. So I'm going to write down even degree. The leading coefficient is negative 0.5. So we have a negative leading coefficient. The negative leading coefficient tells me that the right side of this graph is going to point down. Even means that the other side is going to do the same thing. Now this graph might end up looking like some wonky, like upside down W or M or something. I don't really care what the middle looks like. I only care about the end behavior. So what is the left end doing and what is the right end doing? In the next one, our degree is 3. 3 is an odd number. So this is an odd degree. Odd opposite, they're going to point in opposite directions. The leading coefficient is positive 0.25. So we have a positive leading coefficient. Positive leading coefficient means the right side points up. Odd degree means that the left side is going to point in the opposite direction. Pause the video and try C and D on your own. Okay, I'm going to kind of do these in an opposite order that I did before. The leading coefficient is 3. That is a positive number. So positive leading coefficient means right side points up. The degree is 2. That's even. Even degree means the left side does the same thing. In D, the leading coefficient is negative 2. That is a negative leading coefficient. So the right side is going to point down. And the degree is 5. That's an odd degree. So the left side is going to point in the opposite direction. One of the reasons we learn this is a lot of your assignments for this are going to be multiple choice. If I give you several different graphs and a couple of different polynomials, using the degree and the leading coefficient, you can often match the graph to the polynomial using just that knowledge. So in example 4, what is the degree? What is the leading coefficient based on this picture? So in this picture, I notice that the right side points up. That means it has a positive leading coefficient. I notice that the left side points in the opposite direction. So that means an odd degree, odd opposite. See if you can figure out B on your own. The right side points down. That means it is a negative leading coefficient. The left side points in the same direction, even, same. So that is an even degree. That's the end of your notes for part 1. Your assignment is in Big Ideas. Remember, BIM stands for Big Ideas Math. It's called 4.1 Part 1. Remember, you log in through Clever, then find the button that says Big Ideas Learning. It's the large blue B. And then find in your assignments tab 4.1, Part 1. If you heard that in the video, that's kind of a funny end of the video. Have fun.